Have you ever used an online translator and just stopped for a second and thought, wow, this sounds human? It feels like actual magic, right? Turning these complex ideas from one language into another in like a split second. But trust me, it wasn't always this good. For decades, machine translation was, let's just say, clumsy, way too literal, and honestly pretty funny for all the wrong reasons. So today, we're going to dive into the incredible technology that made this giant leap possible, neural machine translation.
Okay, check this out. This is a perfect example. The old way of translating an idiom, like kick the bucket, would literally give you patear el balde in Spanish. I mean, that means to physically kick a pail. Sure, it's a word-for-word translation, but in terms of meaning, it's total nonsense. Now, the new way gives us estirar la pata. It's a completely different phrase, but it's a Spanish idiom that also means to die. See the difference? It captures the meaning, not just the words.
So, what changed, right? How did we get from that clunky literal translation to one that actually gets nuance and culture? That is the big question we're going to tackle. And the answer, well, it's all about a completely new way of thinking about artificial intelligence.
To really appreciate this breakthrough, we first have to flip back a few pages and look at the old playbook. Before machines could truly learn a language, we had to spoon-feed them very, very specific instructions. It all started with what we call rule-based systems. These were basically enormous digital dictionaries with thousands of grammar rules that were handwritten by linguists. They kind of worked for really simple sentences, but they would just completely fall apart with anything complex. Then came statistical models, which were a big step up. They would analyze huge libraries of text to figure out the most probable translation for a word or a short phrase. It was definitely better, but they still really struggled with a bigger picture, with context and longer sentences. And all of this really just set the stage for the real game changer, neural machine translation, or NMT.
And see, NMT isn't just a small improvement. It's a totally different way of thinking about translation. Instead of memorizing rules or just playing the odds with probability, it uses AI to try and mimic how a human brain actually learns a language.
Here's the most important difference. NMT does not translate word by word. It reads the entire sentence, digests the full meaning, the context, the whole vibe, and then it generates a brand new sentence in the other language. It's the difference between just swapping out parts and truly understanding an idea.
So how does it actually think? It sounds incredibly complicated, and don't get me wrong, it is, but the core concept is actually surprisingly elegant. Let's pop the hood for a second and see the basic idea behind how it works.
So, the classic NMT model uses something called an encoder-decoder architecture. The best way to think about it is like a meaning compressor and rebuilder. First, the encoder reads the original sentence and squishes its entire meaning down into a compact numerical code. We call this a context vector. Then the decoder takes that one little vector and uses it like a blueprint to build a completely new sentence, word by word, in the new language.
Now, this worked pretty well, but it had a big weakness: long sentences. The model could literally forget the beginning of the sentence by the time it got to the end. The massive breakthrough that fixed this was something called the attention mechanism. Its whole job? To let the model focus on the most important parts of the original sentence as it's translating.
The attention mechanism is just like a spotlight. As the decoder is building the new sentence, that spotlight scans back over the original sentence, highlighting which words are most important for figuring out the very next word. This simple but incredibly powerful idea totally transformed the quality of translation, especially for those long, complicated sentences. But the evolution didn't stop there. The next huge leap was the transformer architecture. And this is the technology that powers the services we all use every day, like Google Translate and DeepL. Think of it like this. If the old attention mechanism was a single spotlight, the transformer's self-attention is like having a spotlight for every single word, all pointing at every other word, all at the same time. This lets it understand the super complex relationships between all the words at once, which gives it an incredible grasp of context and makes it way faster to train.
Okay, so this technology is obviously not just stuck in a lab somewhere. The NMT revolution has had a massive real-world impact. But it's not a perfect fairy tale. There are some incredible advantages, but also some pretty significant challenges we need to talk about. What's really cool is how these advantages all build on each other. Because it has such a high understanding of context, NMT is way better at handling words that could mean multiple things. And that leads to the smooth, almost human-sounding translations we're all used to now. And the best part? The more data it sees, the smarter it gets. It's always learning.
But on the flip side, it's not perfect. NMT models are incredibly data hungry. They need massive translated text to learn from, and those just don't exist for every language. They also take a ton of computer power to train, and they can still get tripped up by really rare words or brand new slang.
Still, even with those challenges, NMT is basically woven into the fabric of our digital lives. It's not just the big websites. It's the tech that's powering real-time translation in your video calls on Skype or Zoom. It's helping companies offer customer support in dozens of languages, and it's letting creators share their work with a global audience almost instantly.
All of this is pointing toward a really fascinating future, isn't it? We are moving so fast towards a world where language is way less of a barrier than it's ever been. So, what comes next?
Well, researchers are working like crazy to bring this amazing translation quality to languages that don't have a lot of data. We're also starting to see personalized models that can actually learn your unique way of speaking or writing. And pretty soon, translation is just going to be seamlessly built into everything, from our AI assistants to systems that can translate text, your voice, and even words in a picture all at the same time.
And this brings us to a final, pretty profound thought. As this technology just keeps getting better and faster and more accessible, are we walking into an era where language is no longer a barrier that divides us, but instead it's a bridge that can truly connect us? It's a powerful question to think about, and the answer is being written right now by the very technology we just talked about.